There's no future where chips are less important than they are today.
From EE Tech and All About Circuits, this is Moore's Lobby. I'm your host, Daniel Bogdanoff. At the core of every IoT device is an integrated circuit, a chip under the hood that makes that IoT device tick. Today, we're joined by one of the people who makes these chips a reality, Daniel Cooley, the Chief Technology Officer and SVP of Technology and Product Development at Silicon Labs. It's our first Double Daniel episode. We'll dig into how new IoT specs are born, whether or not it's fair to call RF engineering a dark art, what it's like to go from intern to CTO, and if it's possible to take IoT too far. Daniel, thanks for being here today.
Thanks for having me, Daniel.
I'm curious, how did you first get into the world of technology and what gets you excited about tech today?
Great question. I actually was probably a latecomer compared to most people getting into tech. I really didn't get into it till I was well into college. When I was in high school and in the beginning of college, I had my mindset on being in music professionally. But I had to make a shift after about the second year of school and got deep into tech and fell in love with it. Just came across the right company at the right time and, have stayed ever since.
Do you have an instrument of choice?
Clarinet, classical clarinet and piano.
Cool. Yeah, I saw you were on the board of the Austin Symphony Orchestra. So
Yep.
I'll not let myself get sidetracked by that. But how did you end up at Silicon Labs?
Well, it was an internship, actually. Silicon Labs was really riding the wave of the internet itself, making products for modems and computers and the first radios that went into cell phones that made them really small. And so they were doing some really cool tech, and I came along at a perfect time.
Well, the late 90s, early thousands was kind of rough for that area, right?
I'll say though, it was the right time for Scilabs, but it was a horrible time to go into tech. We were in the middle of the dot-com bust. It was hard to find jobs. I think I was going to be work at a bookstore that summer or telemarketing before this came along. So I was really fortunate to come along, and the internet itself carried Scilabs through, but it was a real tough time entering the job market back then.
Well, it was a tough time to be in telecom as well, and internet. So to see Silicon Labs, come through that maybe even stronger, and you saw that whole evolution from where it was to where it is now. Can you talk about some of the technological mindsets and approaches that Silicon Labs takes to wireless communications at large?
Sure. I mean, that's a really good question because Scilabs has transitioned a couple times over its history, and I got to see it all. When we started as a company, we were really a technique or a capability looking for a market. We were one of the first companies to do digital CMOS, so analog circuits in digital technologies in CMOS. And so we were designing out of old BiCMOS or bipolar designs. So mixed signal, analog, mixed signal RF was our calling card. And there was a lot of technology to put into computers and phones and TVs and things like that. But eventually everybody figured that out. And so we had to migrate to different diversified strategies and ended up settling on embedded wireless or IoT, as a lot of people know it as, where we decided to kind of, instead of trying to find a problem in a bunch of different markets and solve it with mixed signal, we wanted to find a market to sit in for a long time and really just, do generation after generation of products within it.
So IoT is definitely something that was, a buzzword maybe 8-10 years ago, but is clearly exploding. What does IoT mean to Silicon Labs?
For us, it means taking embedded computers and connecting them to the internet. And that typically gets done through a wireless link. It's just easiest to do it wirelessly instead of laying wire. But some people do that too, Ethernet or old wireless protocols. But we got into this business because we had the lowest power MCUs in the world about 15 years ago. And so they were going into very battery constrained applications. And we acquired a sub-gigahertz wireless company called Integration Associates. And so we saw this marriage of kind of low-end compute or constrained compute and, again, constrained wireless bandwidth. So, very long range and very low bandwidth. And we saw our customers doing all kinds of crazy stuff with it. And so we're like, hey, this is going to be really, really big once some other things happen. Like we needed smartphones and we needed the cloud and we needed a whole bunch of stuff to happen in the interim. But then, Apple launched the iPhone 4S or iPhone 4C Bluetooth, and then the cloud got built by Netflix and others. And so now this whole IoT thing's really happening.
What is uniquely hard or different about creating chips for IoT versus a more typical chip?
We're specialized in wireless, which is a very, very hard technology to consume if that's not your business. Like if you're building a phone, it's a wireless product. That's kind of the defining feature of a smartphone, is that it's wireless. A lot of our customers are not wireless experts. They are metal benders. They are experts in building their product, whether it's a washing machine, an electric meter, a shelf label, or whatever it is. And so we have to bring that wireless technology to them in ways that they can consume it. And that is not easy to do. Doing very constrained wireless that's very easy to use is actually a really hard problem. It puts more onus on the supplier. We don't have necessarily wireless experts to hand our product over to kind of go that last mile. So keeping up with the standards, doing all the regulatory requirements, just making RF work in general on a board is not the easiest thing to do. When maybe the most complicated thing you had before then was a microcontroller sitting on that board. So doing all of this in very constrained way that doesn't, destroy the unit economics of that product is the hard thing to do. So think about it like sending the shuttle to the moon the first time. They had to do it with very constrained computers on very constrained power budgets. That's kind of what we do. We don't have a data center, sucking down kilowatts or bandwidth thrown wide open like in 5G. We have to do it all very constrained.
Yeah, I was repairing one of our microwaves at one point, and the circuit board had like a trace that blew out. But it was like FR1 through-hole components, and trying to integrate modern wireless tech into that. It seems like such an interesting challenge.
That's what we do. I mean, that is hard. And, that FR1 is like a little bit better than cardboard. And here you are trying to drop a pretty sophisticated wireless, protocol into the application, and it transforms the application. I guarantee you, once they put wireless in, the next generation of that product becomes way more feature rich. So in some ways, adding the wireless is just the first step to kind of rethinking the product altogether.
As a wireless professional, how do you feel about the analogy of wireless RF engineering being kind of a dark art?
I don't know. I am an RF engineer by training. I'm an RF chip designer. I'm very aware of that's how it's viewed in the industry, and that's okay. To me, it's Maxwell's equations and fields flowing around. And if you can get your mind wrapped around that, the RF all of a sudden becomes not so complicated. But it is very hard to penetrate if you don't understand first principles on how it works. If you are trying to attack it as a system of equations that you solve, you will never get the physical insight and understanding to how it works. If you're not able to think seamlessly between frequency and time domain, and we get trained in frequency domain because it's convenient, but the real stuff happens in the time domain a lot. Then a lot of the things that happen that hold you up, like spur mitigation and harmonics get kind of wonky. But I love it. I got into this. That's what got me excited about tech, was specifically RF circuits and doing that in a very, very small way. I wish more people would attack it. I truly believe it's not as hard as everybody thinks it is, if you can just get your mind over a few critical first few hurdles.
That's great advice. Yeah, I love that answer. What sort of conversations do you have to have with folks? So say a big, OEM type company comes in and says, I want to put a RF chip in my washing machine to make it a smart washing machine. How do you have to guide them through that process? What sort of questions are they asking, and what surprises them?
It's not as common these days as it was 10 years ago, 10 years ago. I'll just, say that most companies have gotten through that initial wave of, I need to put wireless in my thing. Whether it was driven top down at the company or bottom up, they've kind of cut their teeth on it, and they've done that. But 5 years ago, 10 years ago, they really, didn't necessarily know what protocol to put in. They didn't necessarily know the difference between Bluetooth and Wi-Fi or Thread or Zigbee or Z-Wave or the ocean of wireless protocols that are out there in the world. They may not understand the FCC and ETSI and Arab kind of regulatory requirements to live in the ISM bands, in a good way. They may not know how to manage that device. Typically, they thought adding the wireless into the device was going to be the hardest part, and it is hard. But then you have to manage that device, and you say, okay, I need a team now of folks to catch the data coming off those devices, re-upload software to those devices, manage them securely. It's like, we don't just have an IT department. We have to have an OT, operational technology department. And so they weren't necessarily used to writing apps, or they weren't cloud apps or mobile apps. And so, they had to, Gen 1 was get it connected. Gen 2 was kind of like that whole backend infrastructure. Now most folks have got it, their arms wrapped around it, and are doing all kinds of cool stuff.
Would Gen 3 then be kind of a make it safe sort of conversation, or how does security play in?
Security is very important. We have the leading security technology in embedded computing. So we've been investing in it for about a decade. We were actually, for the engineering side of the world, we were the lead partner on the Cortex M33 that ARM put together, which had a lot of this first security in the Cortex M realm. Since then, we've been investing deeply in it. Not all customers are there yet. Half are doing it, half know they're going to have to do it. I think the real critical step on security is when you have to switch from bare metal to real-time operating systems. Like, that's when everything really scales. If you're going to do a cloud connection, cloud can't connect to bare metal things very well. OSs need to talk to OSs. And so when they make that jump, usually that's when security becomes really, really important. It's for lifecycle management, for IP protection, for unique identity, for attestation, for secure supply chain, for whatever reason. We're seeing tons and tons of this now. So half are there and half aren't. And it's usually when people have to switch from a bare metal, main loop into some, task manager and operating system.
How smart is your house?
I'm kind of middle of the road. I have 4 little children, and I don't get a whole lot of time. Let's just baseline it right there.
That's fair. I have 4 kids. I understand.
All right, you're one of the initiated then. That I'd say, I counted the number of wireless chips in my house. It was about 270.
Whoa.
So there's not a small number, okay? But I'm counting the Wi-Fi in my TV, my Nest thermostat. There's some stuff that people have that's pretty basic at this point, but I've gone a step further in some ways. My pool pump is controlled this way. I have wireless connectivity in all my circuit breakers in the house, so I can see them when they flip. So I've had some problems before in the past, and I just redid the whole system, and it was nice. So there's a little bit of mix, but I'd say if I have more time, I would definitely be putting more, wireless chips. I want to get it up to 500 one day.
Okay, you have like I picture one of those like thermometer fundraisers, but it's for how many wireless chips you have in your house, and you're coloring in a little bit.
There you go. Maybe I'll get my kids in on it.
There you go. I really want to ask if there's any brands you would never put in your house, but I won't do that to you.
No, I'd say there's some very innovative brands out there. They don't always make it. It's not the, when we say IoT, it's not the internet side that wins. It's the people that get really good at making the things. And those are traditionally older companies and that have had to work their business models out. If you're attacking it with a very innovative idea with no business model, you typically don't make it, not because of the technology, because the business model. So I just say, be careful what you invest in, because they're not always necessarily going to be around, and switching costs can be pretty high.
Well, speaking of business models, it's time for a quick break, but we'll be right back. Today's podcast is sponsored by Mouser Electronics. As your design fulfillment distributor, Mouser is your authorized source for millions of components from thousands of leading brands. Come discover, design, develop. Visit Mouser.com. And now back to our episode with Daniel Cooley, CTO of Silicon Labs. Are there any examples of products or things, in this case, that really just encapsulate this is a perfect use case for IoT? And are there any that you've seen that you can say, like, we just should not have done IoT for that thing?
Yeah. Oh, man, so many. So I used to run our IoT business before I had this job, and I used to have these called the IoT in action slides. Because, 10 years ago, we were trying to evangelize and get everybody really excited. My sales teams, the ecosystems, they're like, why do you have to add wireless at all? Why does it matter? And so I had all these IoT in action slides. I think a couple that stand out that are perfect use cases. One that's more industrial, I'd say, or commercial, is shelf labels. The most basic technology, a piece of paper. We're not adding wireless to a thing that already has a computer. It's changing out a piece of paper. But you put this wireless shelf label on a shelf, and it changes the business that it's going into. And it's not obvious up front. You think, oh, now they can just update the prices, remotely. Okay, well, that's great. That's step one. That's like, okay, it is way cheaper to do pricing in a store. And if I used to work in retail when I was in high school, and doing inventory and pricing was, man, it was so hard for them to do as a bookstore. But then all these other things start happening. Okay, now they can advertise coupons on these things. Okay, now they can do dynamic pricing. We have South by Southwest in Austin right now, and I promise you that prices have gone up while everybody from out of town is shopping. Then they can have lower legal liability. There's actually a lot of issues on price matching between the register and the shelves. And there's several court cases that have gotten, I don't want to call any companies out, but some of my customers have put shelf labels in their stores just to get rid of the regulators coming after them because, the price on the shelf was some price, the price on the register was higher, and that's illegal.
Fascinating.
There's a certain range you have to live in there. So they're like, okay, we're tired of getting taken to court over this. We're just going to put shelf labels in and we can manage all this stuff all at once. So there's a lot of things that can change by just adding that little wireless capability on something like a shelf label. Another similar story that I always tell is like power tools. We have one of our customers putting Bluetooth into power tools, and it's like these things are ancient. Like, why would you ever need to do that? They make the tool so much better, and these aren't necessarily brands that are DIY. People do have it for that, but this is professional brands. This is like, contractors who are being paid $100, $200 an hour to come do this stuff, but they add wireless capabilities into the tool, and all of a sudden the tool is now, you can't steal it, okay, because it needs an unlock code, or you can find it, or it can report self-diagnostic that's about to fail, so it can fail safely and not catastrophically in someone's hands. You can find it on a big job construction site, where it takes 2 years to build a building and they dump up a bunch of tools. Now you can find it instead of having to go pay somebody half an hour to figure out where it's at. You can even change the performance of the tool by locking down or capping things like torque and rotational speeds. You can do data logging with it. There's a tremendous amount of regulation around building and electrical systems and plumbing systems in big buildings. They want to see logs of the crimping on power. I mean, you can do so much now that you couldn't do before. Even when the tools get sent back, the first thing they do is dump a bunch of data off it through the wireless link, for repair or something. So, it's like, okay, I finally see and I finally understand, like, okay, why someone would do that, and it would make the tool a better tool. So usually the home run cases aren't where wireless is the feature. It's where wireless made that product better. And that's what our customers are really trying to do, is make better products, not do kitschy wireless for the sake of wireless. And here's a counter example. We had a customer place many million unit order once. We were trying to figure out what it was, and it was Bluetooth and fidget spinners back when that was a thing. And I'm like, does the world really need to know the RPM of the fidget spinner? But it just shows you how approachable and how many barriers have come down to really implement this technology. And it's really limited by folks' imagination, that you're able to really take something that 20 years ago was pretty unthinkable and try it out.
Yeah. Fidget spinner leaderboards, though, maybe not what the world needs right now.
No.
It's got to be just a hall sensor and a counter. That's all you need.
It's a simple device, and they have to write an app. Listen, forget that.
That's true. As people are starting to implement more and more IoT, it's everywhere, wireless connectivity. You today at Embedded World are releasing some new IoT chipsets. Can you tell me more about what's happening there?
So we're in our second generation of IoT products. We call it Series 2. And the first gen was really kind of launched back in the 2016, 2017 timeframe. Our newest generation of products are really about driving lower power, higher security, and more performant wireless in about the same footprint. So we're writing our own version of Moore's Law, as you can imagine. Our customers have a certain threshold on cost, board space, complexity that they can absorb. And so, this next generation of products, we're launching chips around that. is more around delivering sub-gigahertz technology, security technology, machine learning technology, in the same footprint as you would normally expect kind of less performant technology.
Can you talk a little bit about like AI ML rollout for edge compute and IoT and what you're seeing in that space?
Great question. And first I'm going to say these are not LLMs. We're not doing generative AI on your toaster. There's just, I cannot, maybe one day, I don't know, maybe the Jetsons or something. But for now, our ML is more about classic machine learning inference. People have been trying to do this forever. I mean, you can imagine a microphone on a traffic light that's trying to detect gunshots or car crashes. So they've had algorithms for this for a while, but now they're just way, way better than they ever could be before because of machine learning and the kind of the revolution that's happened over the last 10 years there. So we're seeing if there's kind of a high fidelity or even a low fidelity sensor, someone is doing machine learning on it. It could be like a lot of them are microphone based and a lot of them are vision based. You can have basic cameras looking for faces or cars or just image detection. But we're seeing even low fidelity interfaces like a simple PIR sensor in a room trying to determine if it's a person or a dog. Or do people counting, just a rough people counting, how many people are here. And that's really kind of helpful for, in a security system, the reduction in false positives that happens. And so these systems become safer once there's these other mechanisms to kind of qualify a break-in. Okay, that really was glass breaking. There really is somebody there. Call the police. So the police will come out, and these security companies are working with local law enforcement saying, my system has all of these capabilities. When we call you, it's for real. You need to come. Because false positives are the worst thing in the security sensor world because the emergency services don't come. We're also seeing basic sensors in health, measuring all kinds of things coming off the body, trying to determine, simple heuristics like how long was I asleep? Or more complicated things like, is my blood glucose spiking right now? Do I need to do something about that? So we're seeing a ton of ML coming out, and it's still early days in embedded, to be honest. We've got, accelerators and all kinds of demos and sensor applications for our products, but we're still at the early days. We're kind of today in machine learning where security was 5 years ago. So customers are now just saying, well, what do I do with machine learning? Like I kind of know I'm going to need it at some point, but I don't have training data for it. I don't know what algorithms to implement. Everything seems to be moving so darn fast. And once I kind of put this out there, how do I protect it so no one can swipe all that data? And so they're just on the front end of this and embedded. It'll take another 10 years before it really blossoms, in my opinion.
What is an AI ML accelerator, and how is that different from like a standard training or like tiny ML approach? So
we don't do training on our devices. Just say that. Training is still only really feasible on a higher end thing. You could do basic training on a computer for an embedded application, but most people are still doing training in the cloud. The inference side, though, can be done extremely efficiently. We can do big implementations on a battery, at this point. And there's several companies, not just mine, that are building products just for that. So what we do is we put accelerators in our chip that are doing extremely efficient math operations that are kind of core to all of the algorithms, convolutions, any kind of the math, matrix multiplication that you might need. That's kind of a standard primitive of these ciphers, of these algorithms. And in many cases, they're not that different from some of the security stuff. A lot of the security is built on similar math. So we have these accelerators out there, and then at runtime, you can choose to run the algorithm on a standard processor, or you can send the workload to these accelerators the same way we do in security. You can implement an RSA algorithm or something, a JPEG key exchange exercise on the CPU, and just like let it do its math and crank. Or you can send it to the accelerator and have it come back lower power, more secure and faster. It's a very, very similar analogy.
So this new chipsets, I see they're 8 times faster, 6 times lower power. Like they're definitely a step up. If someone wants to implement one of those, and this kind of goes back to the conversation of if I want to put a smart chip on my FR1 microwave board, how do developers and designers actually go about making this reality for them?
That's a great question. We're one of the best to sell to a broad market. And broad market wireless is really different than kind of extremely narrow market wireless that you might find in a phone or a computer. So we have a vibrant community with easy to approach dev kits and boards that you can get with demos that work, out of the box with a mobile app. The kind of wireless version of Hello World is pretty quick and clean to run. Our goal is to get folks running up and running as fast as possible on whichever wireless protocol they want to use, and really get you going on your back to your application, not necessarily trying to debug the wireless links.
And you just announced a partnership with Arduino to do some Matter protocol stuff. Can you outline what is the Matter protocol and what does your partnership with Arduino look like?
So Matter is a new wireless protocol that runs over multiple physical layers. So it runs over Thread, it runs over Wi-Fi, and it runs over Ethernet. The whole point of this is to kind of have a protocol that's independent of the physical layer as it's running so that you can have common consistency across these protocols. One of the hardest things on the wireless protocols in IoT has been they don't talk to each other very well because many of the protocols are defining the physical and application layers. So Matter is sitting in that application layer, doesn't necessarily care what physical layer it's running on. We sell into both the Wi-Fi and the Thread portion of this. So Thread is a 15.4, IEEE 15.4 mesh networking protocol. It's a little bit different than the star networks that Wi-Fi typically runs. They're just for different use cases, really. Wi-Fi was more built for consumer applications like phones and PCs. And the 15.4 meshes were really more conceived about network resilience and getting 1 bit or 1 byte of traffic through that network as reliably as possible. So they serve just different use cases. And so we are partnered with Arduino now to make that as easy as possible for the big community that they've cultivated. Again, we come back to, we want to sell wireless to everybody. That is our goal as a company. You should not be worried about whether Scilabs wants to do business with you or not, or Silicon Labs does business with you or not. We will do business. And not every wireless company approaches it that way. You might have to sign 10 NDAs to get a data sheet. Here, we want to make it as easy as possible. And Arduino has built up one of the best communities in the world. It doesn't necessarily have all the wireless capabilities, though. So Arduino is really built for processors, microcontrollers, and testing things out. And now those MCUs need to connect to something. And that's classic hallmark of IoT. So we were happy to step in with them. We want to do as much virtualization and ease of use as possible for that community.
Yeah, we actually had Massimo Bonzi for episode 23 of this podcast, and he talked a lot about them working to move from the kind of hobbyist makerspace, but also expanding into more professional commercial areas. Can you talk about just a little more about what that collaboration looks like and how Silicon Labs specifically might show up on an Arduino later?
I don't want to give all the plans away, but it is important to expand into both communities. The hobbyist community is real and it's big and it's growing. And I think that's a great thing. It's the only approachable kind of electronic market, if you will, out there. And there's a lot of pure software ones. It's way more easy to write an app for your phone as a hobbyist than it is to necessarily start breadboarding and making hardware. So this is the best way to do it, and that's really good. That being said, most of the volume in the world gets shipped by professionals, and a lot of them are doing both. There's like an overlap there. So I understand why Arduino it needs to kind of grow out of the hobbyist roots. Never give that up, and I think it's great for the world that it exists. But we do have to kind of branch in the professional side, and Scilabs is a good partner for that. We're the number one wireless supplier into the IoT. That's what we do. And so we've cut our teeth selling more than 1 billion wireless chips over many, many years. We've gotten to all the corner cases of the specifications. Our stacks are rock solid. Our board designs are going to pass your certs. We have modules, we have chip down, whatever the people want. So we're a good partner to them to kind of reach into the more professional side of the world.
So as you're doing these partnerships and looking at the world of tech at large, where does the technology go from here? Where do you see IoT and wireless communications going in the next 5 years, 15 years, 50 years?
Oh, that's such a good question. I actually spend way more time than you might think thinking about this. So here's the contours of a prediction for the answer. Most of the embedded community has spent a good time trying to figure out how to add this capability into their product and into their backends, like we talked about. And once they've done that, the cloud kind of comes down into the application. The same way that your laptop today it's kind of built to connect to the internet, actually, in a highly assisted way. Future products in the embedded space are going to be built the same way. And as the cloud comes down, you're going to see a kind of stratification of compute. People are going to want to preserve and maximize the compute in the far end device. They're going to want to limit the amount of data they're sending over the network. Bandwidth is precious and expensive, and it's very expensive to fire up a power amplifier from a power perspective and transmit data if you don't have to. So they're going to put as much compute as they can at the farthest edge as they can every time. And so the cloud is going to come down. Memory, processing, sensing, machine learning, security, all of these things are going to come out of the cloud on their way down. It's not just going to be a hub somewhere that's going to be the smart thing. They're going to put it all the way at the edge if they can. Second thing that's going to happen is we're going to see kind of a change in the core technology inside of the embedded products. So these MCUs and these wireless chips that are sitting next to each other are going to merge wherever they can into a single kind of wireless MCU. And that's going to drive another wave of efficiency and performance and capabilities into those embedded systems. Economics are going to drive it, but also managing one code base instead of two code bases. It's easier to secure that device. There's a whole host of reasons, smaller PCB footprint. Like there's a whole host of reasons why these things are going to merge. So if you're a chip supplier or if you buy chips, which more people buy chips than make chips, you should start looking for those roadmaps to be popping up out of the chip companies. In the long run, 50 years, I think the IoT is really going to be the nervous system of whatever AI is kind of running our economy at that point.
Sure.
It's not going to be people-based. I think the internet and the data centers are not going to be built for people like they are today. They're built around serving up Facebook data as fast as possible wherever it's needed, or TikTok, or whatever people are doing these days. I think there's going to be a shift into data centers and the infrastructure that it connects to built around the trillions with a T of electronic things, which will far outnumber the people. And so I think there's going to be a rethinking of infrastructure, internet infrastructure, away from human-driven activity and human-driven economics into machine-based ones. And it's going to be a thirst for data that the IoT is collecting to train on. There's going to be, the quantification of the implementations is going to be driven through the IoT. So I think in the end, there's going to be a shift away from, it's nice to have, an electronic shelf label, into something else. It's like a requirement for, the next version of the machine learning algorithm that's going to tie weather to pricing to fruit spoilage or something crazy like that.
Yeah.
So in a super long-term frame, I think there's going to be a rethinking of internet infrastructure around non-human electronic devices. And a PC is a human-driven one. I hold it. I touch it. I look at it. You're only going to sell 100 million a year. But once you disconnect the human side, these things can get into the hundreds of billions or trillions of units. And that's when everything's going to change.
And it's a totally different set of requirements and constraints if you're talking to computers and chips instead of delivering, video to people. Yeah.
And, the embedded community is fighting in all the standards to undo all that kind of thinking right now. Wi-Fi is a really, really good example of that. It's a technology that was built for content more than data. And I say, okay, what's content? Content's my Netflix stream to my TV or my Dropbox syncing or something like that. Data could be a security sensor going off, or it could be a door that's open, or it could be, some critical byte or bit of information. And so even within Wi-Fi, the new Wi-Fi 7 standard is going to do all kinds of cool stuff for IoT, more so even than phones and PCs. And so that's really, really exciting to see. We're going to have different quality of service metrics, like maybe my smoke detector on Wi-Fi will get priority over Netflix. And now you can do that within the standard. the same way cell phone systems can do in like 5G and 6G. So you're going to see a rethinking of the wireless standards, how the ISM bands are used, a whole bunch of cool stuff as the internet infrastructure shifts away from people and into things.
Since you're one of the people who has to look at new specs that are coming out and deciding, yes, we build a chip for that, no, we don't, how do you evaluate a spec for viability?
Really good. I mean, we get in very early. By the time a spec is being published, we've been looking at it for years. So we're influencing it as it goes through. Matter is a really good example of that. Matter is a great standard, but it's had a lot of cooks in the kitchen, from the cloud side, from the big brands, from the embedded side. And there was times when we had to kind of jump in and say, hey, big company X, you have
not
to
actually X, but yeah.
Oh, sorry. Yeah, not actually X. But there were some big companies who they don't really know how to think real small. And the specifications they were trying to drive into the standard would have just broken the economics. Like there would be no chips. No one would build it. And we're like, hey, you have got to make that smaller. And they're like, well, how do we do that? And I'm like, well, you have to let go of Linux. And they're like, well, wow, that's a big thing for us. And we're like, okay, yeah, but we're going to get down into real-time operating systems. And here's how it's going to work. And so we're able to kind of pull the standard back into something that you can actually put into a light bulb. And your light bulb will not run Linux. I promise you. And so, there's an important piece we play in terms of balancing what's feasible versus what's perfect.
When you look at the spectrum and what frequencies are being used for what's your take on the ISM bands like RFID versus going up to, millimeter wave where there's just kind of blue ocean frequencies?
Yeah, that's a great question. I think the ISM bands are like one of the greatest gifts to humanity that governments didn't realize they were giving when they gave it, or they would have charged a lot more. But all the data that we use and consume is mostly sitting in free spectrum. There's a significant amount that's licensed spectrum, but most of it's going through unlicensed spectrum. And we're starting to see governments now look a little harder at those licensed unlicensed spectrums, like the ISM bands themselves, and do things like in the US and in most of Europe right now, they're allocating another gigahertz of bandwidth for Wi-Fi. So this is kind of the core of the Wi-Fi 6E or Wi-Fi 7 and beyond standard. And so they're opening up more lanes of traffic, so to speak, or like a Panama Canal for us to ship all our data through. And so, if the ISM bands ever got shut down for whatever reason, like our economy would stop. I mean, period. And so you need them. They're precious. And in the end, when I talk about all these trillions of things 50 years from now, that bandwidth is going to be the most precious resource there is. And all the standards are going to be driven around minimizing on-air time, minimizing bandwidth, and getting the maximum bang for your buck when you do send something through. And so over time, the big companies and the governments are going to have to grapple with the fact that the spectrum is getting too crowded and not everybody can get on the road at the same time. We're going to have priority. We're going to have more strict requirements to get on the air. But as it is right now, anything can get on the air at any time. So I think over the next couple of decades, as we start to shift away from, again, human-driven internet traffic into machine-driven internet traffic, we're going to see this big tussle happen. And I'm hoping we end up with both. And I think we will. I think engineers are really, really good at figuring out these kind of problems.
You mentioned not everyone being able to be on the road at once. And that reminds me of in China at certain points, there were like even days and odd days for when people could drive based on their license plate number.
Yep.
You lived in China, in Shenzhen, doing work there for a while. What was different and what recommendations do you have for people who are working with teams over there or even potentially relocating themselves over there?
Sure. So yeah, I was actually living in China when that was happening. I lived in China when the car explosion happened, and it went from being a very rare thing to very common. So I have a lot of international experience, and I think every big multinational at this point is a global R&D footprint. The world is kind of dividing. Let's just call it out right now in a way that 10, 15 years ago I didn't think would happen. And I hope 10, 15 years from now we're back to coming together. That being said, in any environment where you're working in kind of big geographic, big cultural, big time shift. You just have to have a common understanding, common way of working. You need to get on a plane and talk to each other sometimes. Like, I love Zoom and what it enables, but it's not a crutch. It doesn't do everything for you. And I think the biggest misconception that I see is that people thinking other people are not capable of doing something. And as long as humans are motivated, they will find a way, period. I'm more convinced of that than ever. And my experience abroad really showed me when folks are hungry and passionate, they'll find a way. And they always do. So, just never go into these things thinking, well, I have the map and nobody else can find the way, or I've got some trade secret, or I've got some patent, whatever it is, folks will find a way to get there. And so people are motivated. They'll find a way to do it. And there's smart people everywhere.
What are your thoughts on ways companies and individuals inside of companies can operate to help kind of bring that back together, change the momentum there?
See each other, talk to each other. The governments are making it harder. Export controls are being put in place. Tariffs are going to be enacted. Gravity's government being gravity is kind of working against us there, but to the extent that you can, and I'm never saying break the law, never ever do that. You got to, that sets you down a whole different path, but no matter what teams you're trying to work with, I think we are still people and we need to interact that way. Maybe one day kind of chip GPT is building chips for me and I can just set the LLMs talking to each other. But for now it's human driven. And so any problem you're trying to solve by putting process in place where it's a human problem. And I've seen us do that because we're engineers and we love processes and checklists and, protocols and all that kind of stuff. Whenever you're trying to put protocols in place to solve a personal or human-driven problem, it breaks in the end. So just call it out for what it is. Get on a plane, see each other, talk to each other at conferences. Is communicate is the number one thing that you can do in these instances. And I know that sounds like motherhood and apple pie, but the longer I do this, and we have teams all over the world, just the more true it is in my mind.
Yeah. No, I love that. I've had some of my most fruitful meetings have been with folks that I've talked a lot to over cameras, but we made so much more progress in person. So
the whiteboard is a sacred place. Like, I've got one right next to me here as we're talking. Like that's if I guess if the virtual reality or AR people could replace that experience somehow and it feels real, maybe they've cracked it. Like, if I could sit at a virtual whiteboard with somebody and have the same experience as a physical whiteboard, maybe everything I just said goes out the window. I don't really know, but that's a long way off.
Yeah. So you've spent almost 20 years at Silicon Labs from intern to CTO. Can you tell me about that path and maybe some things you've learned along the way that really serve you now?
It's not very common for folks to sit at a company, and maybe it was a long time ago, but these days it's not as common anymore. But I think it'll become more common in semiconductors because there's fewer companies. And some things that I've seen along the way are that, when opportunity comes, it's a random process. You can't plan it. You have to lean in and grab it if you're ready for it. And if you're not, don't. And if you're not sure, just do it. You gotta have enough value-driven and principle-driven ways of thinking, and you'll get there. With solid fundamentals, you can solve almost any problem. And so there's been moments where opportunity presents itself and I jump at it and I lean in and it can feel kind of lonely when you're doing that, and that's okay. And then you're going to fail. If you're not failing, you're probably not trying enough or trying hard enough at what you're doing. So you have to get comfortable. I say you're not going to like it. Okay. It's not about liking, like, I failed. This is amazing. But getting comfortable that failure is a part of your job. If you're doing anything big and hard, and if you're not doing anything big and hard, you're probably not doing anything valuable, and your company's not going to make it. So you always have to be living at that edge, in technology especially. If you're not pushing state of the art, what are you doing? You better have some other way of surviving. And at Scilabs, we've always been pushing state of the art. I guess the other thing I'd say is if you ever are making a career transition, you've got to go back to the basics. And I see a lot of folks struggle with that. And I've moved from R&D into kind of product management and general management. I did M&A and strategy for a while at this company, and then I kind of back to R&D. So all the way around in the circle from R&D to businesses to G&A back to R&D. And a lot of folks get really productive and good at what they do. And you try to step into something new for whatever reason. Okay, I'm not going to pretend I know the reason. If you're not afraid to kind of get humble and go back to the basics, you're not going to make it. And some folks just, they get used to being productive. They get comfortable with being good at what they do. And the idea of going back to the beginning is too hard. Or they try to, skip the steps that got them to where they're at. And so if you're going to go do that, be prepared to go back to the basics and learn. And you got to be curious, and you got to, you can't skip those steps. So that's another piece of advice that I give a lot when I get that question.
No shortcuts, and short circuits are maybe a bad thing.
Yeah, I mean, you could definitely slow things down, but you can't skip steps. There's an order to getting good at things, and you can't hop around every 2 years. You can only do it a few times, but if you do it, you can start connecting so many dots that you never could before. Just because we only see different pieces of the pie or the circle or whatever you want to say, and then you live on different pieces of it, and then you see how it all connects together, and then it's like, oh my God, this is how it all works.
Yeah. Do you have any projects that you look back on most fondly?
Oh yeah, many. Just a couple. I remember measuring my first circuit on the bench. I was doing an ADC. This is more technical, Sigma Delta Bandpass ADC. And the first thing you do is short the inputs together and plot the noise transfer function. And I did that. And I was like, oh my God, it was exactly like the simulation. Like, that's when I was like, the magic of these crazy complex transistor models I was like, holy crap.
Yeah.
That was a big moment. I did a big chip for my first chip in Shenzhen for a very big customer. And it was carrying the whole division at the time because they were doing some very, very far out in investments. And we knocked it out of the park. I'd say we worked harder than we've ever had to work before. But we got there, and it sold into many hundreds of millions of units and made a ton of money and kind of carried the financials. Lots of projects, Daniel. I mean, I love that stuff. On the M&A side, I did a lot of big stuff, including breaking the company up. And, there was lots of things I'm proud of. I had a lot of failures too. I'll just be honest with it. But, I've learned from those.
Do you want to share a failure, or do you want me to not ask that question?
Absolutely. Yeah. People should ask this question more often.
Okay. I love it. I might leave that in. Can you share a time where you really just, you swung hard and you struck out?
Yeah, I can. And I wish people ask that question more often. It's so easy to talk about successes. I remember stating at a whiteboard, explaining to my boss why the next generation of a touch controller we were building was going to just solve all the problems. And we were just going to, get all the market share and make all the money. And as I was talking through it, I realized none of it was going to work. And this was circa 2011, say. This is when touch controllers, the only company that had touch controllers at the time was Apple. Samsung and everybody else was trying to catch up with capacitive touch-based screens, and so it was still new. This was a while ago, and it was kind of crazy the way the specifications were evolving, and trying to get multi-touch versus single touch, and a whole they were changing the chemistries of the screens themselves and the sensors. Like, it was a whole bunch of moving pieces, and we thought we'd cracked the nut. This is how we're going to do it better than anybody else, and I realized it was like being punched in the gut. I realized, wait a second, this is not going to work. And I'm not sure there is a differentiated way to do this. And at the moment, that's when I realized pretty much all touch controllers were going to be so tightly integrated to the cell phones themselves. It's really hard to be an independent chip supplier in the long run to do this. And, we ended up exiting that business not long after that. We announced it, I think, in early 2012 that we were getting out of touch controllers. That was, I don't know if failure is the right word.
That's a win.
We didn't set out to get out of this market. We set out to win it, and it was a very tough mixed signal analog problem. And we should be able to tackle this if anybody. We weren't the only one. Atmel got out of it. Like, everybody who had making money at the time had to get out of this market. And in the end, it did kind of get sucked into Apple and sucked into Samsung and others. So, that did play out. But I definitely remember that. I remember a time when I promoted somebody into a role that did not go well. And I think in my gut I knew it. But I needed a solution, and doing nothing was not an answer. And that was probably the most painful lesson is when you have to, fix a problem like that, especially when you created it. That was really tough. Another time we had to close a department that I had been a part of. And, you spend a long time with people and building capabilities, and in semis where we live in the design side, it's all human driven, on design.
Yeah.
Shutting down that department was a big failure of mine. Like I was leading that team for a while. I left that group, had not done my job transitioning leadership to the next leader. There was a leader, of course, but it did not work out. And I felt a lot of responsibility in the end for that team. They stopped performing very well, and we had to close it, and I had to go do it. And that was a huge failure on my part. So, I think we fail on the technical side because what we do is hard. The people side is what sticks with you usually on these things. And, if anybody who's retiring and you ask them that question, maybe ask me in 20 years when I'm retiring, what do you look back on? And those are probably the things that are going to stick out is the people side.
Yeah. I have a moment like that. And I was recently talking to the individual, and they were just thriving. And it made me so happy to just know that like my mistakes there didn't, end their career and they're thriving somewhere else. Like I totally resonate with that.
Yeah. That's where, yes, Oof. I'm glad you had that experience.
Yes, it's still a little raw. So, my reaction to that was like, no, I'm not glad, but you're right. The right answer is yes, it was good to have that experience, which is the point of the question.
Yes.
Okay. We're running out of time. We like to do a lightning round at the end, some quick questions, quick answers. If you could wave a magic wand and either eliminate or create a rule of physics, what would it be?
Oh, okay. Here's a real one. I think about this a lot. And when you're building antennas, they physically have to be a certain size.
Yes.
You have to move the electrons around at a certain distance to make the waves propagate. I would change that rule. I would love to build.
That's a good one.
Yeah, antennas are sometimes the most limiting factor to end product design. It's a pretty esoteric one. You probably get a lot like superconductors and this and that, but this is one that like would actually change products if you could change physics and make them radiate at whatever frequency you want, with whatever efficiency you need, without having to have some complicated twisted metal thing running all the way through it. It's great that we have antennas in the world. They're like our microphones for nature, but they have to be a certain size. And it kills me. And I think about this. That's my lightning answer.
Yeah. If someone can get an antenna that's smaller than a quarter wavelength, I think that'd be a game changer for sure.
Yes.
That's a great answer. Same question. If you wave a magic wand and either create a new spec or get rid of a requirement in an old spec, what would it be?
I would force the ecosystems to make a hard decision and let go of legacy requirements on specs.
Ooh.
There's this concept of kind of like no one left behind, and
yeah,
this has been great because we've had continuity of product technology. If I buy something today, I know it's going to talk to the things I bought yesterday. But I think if we had a step function where we could all just say, everybody clear out the old use cases that don't really, aren't needed anymore. I think you would see an exponential increase of innovation coming. So there's a point when carrying all that legacy is working against you. And it really, this comes around like the ISM bands and the way the specifications work around wireless technology. I'll just leave it at that. I would force us to make a really hard step function, painful, expensive, do it once, and like watch a whole new exponential or S curve emerge out of that.
What another great answer. Last question. Is now a good time to get into chip design, or is AI going to take it all over?
Now is a great time to get into chip design. No, it's not going to take it over. EDA has been making designers more productive as long as I can imagine. Is it going to make us more productive? Yes. Has it been making us productive the whole time? Yes. I firmly believe you're going to need as many sources of data, compute, storage, and transfer as possible going forward. It's going to get, again, disconnected from humans and more into things over time. We need as many different kinds of chips as we can get to make that go. So I think it's a great time to get into design. Fab capacity is being built up like crazy right now. They're going to have to fill those fabs with something. They need really good designs to go do that. I think it's a great time to get into design. And I didn't always think it was, but I absolutely believe there's no future where chips are less important than they are today.
Fantastic. Well, we're definitely out of time. Thank you so much for this conversation. It was really enjoyable for me.
Thank you. I enjoyed that.
Well, that's it for today, but before you skip to the next episode, make sure you're subscribed to this podcast, and please share this episode with someone you think will like it. When you share episodes, you get to be a part of growing Moore's Lobby, and we really appreciate you for it. I'd also love to hear on social media some of your most or least favorite IoT devices, or if you have that IoT fidget spinner, I definitely want to see a picture of it. I'm Daniel Bogdanoff. Thanks for listening today, and I'll catch you next time.